Hi there. So apparently you're here because you need a little review of negative powers. Well, it's quite normal. Everybody struggles with negative powers. But once I show this to you, you'll see that it's not really that hard. So here's the basic idea. Hopefully you remember that what we said the other day, that 2 to the 3 times 2 to the 8, for example, was equal to 2 to the 11, because this is just 2 times 2 times 2, and this is just 2 times 2 times 2, 8 times, so in total it's 2 times itself, 11 times. This idea is pretty easy to understand. Now, what if I do this thing? So what if I do 2 to the 8, and then I divide by 2 to the 3? Well, now, again, I can just do the same thing that I did before. So I can do, this is just 8 times 2, right? I mean, the 2 multiplying itself 8 times. So 2 times 2 times 2 times 2, 2, and so on, 1, 2, 3, 4, 5, 6. I always go to 7. Okay. And then this one under is just 2 times 2 times 2. Now, hopefully you remember from when you did math last year that when this happens, you can cross some 2's out. And remember, you can only do this when they're multiplying. When they're adding up, you can't do that. Anyway, so I'm just like, okay, well, I can cross 1, 2, and 3 2's out. So how many 2's do I have left? Well, I can count, but I know that it's going to be 8 that I had at the beginning, minus 3. So I'm going to have 5 left. Okay, so 2 to the 5. Oh, look at that. It looks as if this 5, I could just get it from 8 minus 3, right? 8 minus 3 equals 5. How is that? Well, simply, if I have 8 2's here, and I subtract 3 of them because they're dividing, then of course I get only 5 left. So then I look at this and I'm like, well, could I express this division sort of like this thing? So that, it all fits together nicely and it looks beautiful. Well, beautiful for a mathematician. I don't know if it looks beautiful to you. It looks beautiful to me. Okay, so, well, I could say, well, yeah, this is the same as saying 2 to the 8 times 2 to the... Now, if I want to subtract the 3, this 3 here should be negative. So I can just write 2 to the 8 times 2 to the minus 3. And that still gives me, if I apply this rule that exponents just add up, I will still get 5. I'm like, oh, well, this is a nice rule. Cool. So I can still use the addition formula. Just whenever I see two exponents of things that are equal multiplying, I can just add them up. But when they're dividing, they're just negative. So really what I'm saying is that 1 over 2 to the 3 is the same as saying 2 to the minus 3. And what gets people really confused is this negative sign. They're like, oh, it must be negative. No, it's not negative. 1 over 2 to the 3 is 1 over 8, which is perfectly positive. It's just really small. The more negative this thing is, the smaller this thing is. So 1 over 2 to the 16th is a very tiny thing, but it's still positive. This negative sign here does not make my number negative. Because remember, this negative sign here just means that it's dividing. That's it. Now, for a little bit more abstraction, but not a lot more. We've seen... Oops. There you go. So, we've seen this thing here. And I asked myself, well, what happens if I multiply 2 to the 8 times 2 to the minus 8? Well, according to this addition rule, right, 3 and 8, 11, I could say, well, 8 minus 8, that should be 0. So I should get 2 to the 0. But what does that mean? Is that supposed to be 0, 2, 320? Well, I have no idea. Whenever I have no idea, I do what I always do, which is I work on what I do know. And what do I know? Well, I know that 2 to the 8 is just 2 times 2 times 2 times 2. I hope I do the counting right. And 8. And I know that 2 to the minus 8 is the same as saying 1 over 2 to the 8. So it's the same as saying, well, this is dividing 2 to the 8. So let's just divide this thing. 2 times 2 times 2 and so on. Do you see how this is a pain? Do you see how this is not something you want to do all day? That's why we use exponents. Okay, well, and then I'm just like, which ones can I cross out? Well, I can cross out this one, and this one, and this one, and so on. And you see that I really can cross them all out, right? Because what I have is one thing divided by itself. And when I have one thing divided by itself, what do I get? Please don't say 0. Don't say 0. It's not 0. It's 1. Yeah? 2 over 2 is 1. How many pieces of sides 2 can I make in 2? Well, 1. 3 over 3 is 1. 5 over 5 is 1, and so on. So 2 to the 8 over 2 to the 8 is 1. So this is equal to 1. Which means that if this equals this and equals to 1, then this has to equal 1. And this will work for any number, not just 2. Any number, 2 to the 0, 3 to the 0, 5 to the 0, x to the 0, whatever you want to the 0 is just equal to 1. So that's the beauty of this thing. Now for one last thing regarding powers of 10. And powers of 10 are way, way easier than powers of 2 because, again, we can just use the decimals to help us. So let me just move this over there. And let's see if for example, what if I see this number? 0.0001. Well, again, this is a little bit of a pain, right? Because at least I get really confused by decimals. I hate them. And that's why I use standard form. Because standard form is easy, decimals are hard. So here I'm like, well, this is the same as saying that this is 1 times some power of 10. This is really the same as saying 1 divided by something. Well, divided by what? Well, if I multiply by 10, it will be here. By 100, it will be here. By 1,000, it will be here. So by 10,000, it will be there. So this is the same as saying 1 divided by 10,000. Okay, cool. But again, that's too much work. So instead of 10,000, I'm going to write 1, 2, 3, 4 zeros. I'm going to write 1 over 10 to the 4. Ugh, that's supposed to be a 10. But now that we're cooler than that, we know that 1 over something is just the same as saying 10 to the minus 4. So really 0.0001 is just 10 to the minus 4. Now you can, now that we know why this happens, we can use some techniques to make this a little easier. And as you could see here, in order to figure out what I had to put here, I just looked at how many times do I need to move the 1 until I get here. So I can do this thing here. I can just go like, well, 1, 2, 3, 4. So I need to multiply this by 10 to the 4, therefore this is 10 to the minus 4. I could do the same thing with 0.0032. Now, if I want to use standard form, and normally I do, by how much would I have to multiply this thing so that this 3 was here? Well, I start here, and I'm just like 1, 2, 3. Or, looking at it the other way, how much do I have to run the comma this way? Well, 1, 2, 3 times. So 3.2. Oops. So 3.2 times 10 to the minus 3. And that's pretty much it. All we need to remember is that this thing does not mean negative. It just means that it's very small. It's divided by 10 to the 3, which is the same as dividing by 1,000. This is divided by 10 to the 4, and so on. Okay, hopefully you got this. I know it's a little abstract. This is math, not physics. But it's worth mastering, because once you use these things, then something as hard as multiplying becomes as easy as just adding up and subtracting. And everybody knows how to add and subtract. Good. Do a little bit more of the quiz, and if you're ready to move on, I'll let you. Otherwise, you'll go back to the video. See you later.